Alright, hello everyone. This is Jake Lawler and I'll be presenting my Math IA. At any point in the video, if you feel like you want to try and solve part of this problem, then feel free to pause the video, and there are of course multiple ways to do every part of this problem. So let's jump right in. This is the problem that I did for my Math IA. So we have a square that's a unit square, which means that it is a 1 by 1 square. And I'm just putting it in the first quadrant for simplicity. And we have two random points, A and B, inside of this square, and the points are uniformly random, which means that any point on this square is equally as likely for both A and B. And of course we have the distance between the 2 points A and B. Now our question is, what is the average distance, D, between A and B? Our average value is simply just a maximum plus a minimum divided by 2. That's essentially what we're going to be doing here. We need to find the minimum distance of D, or the distance between A and B, and we need to find the maximum distance between A and B of D. Right? Well, right off the bat, if we bring back the problem, then we have the option of A and B being right on top of each other. However unlikely it is, it's still very possible, which means that the minimum value of A and B is 0. Equals 0. Now, the maximum gets a little bit more complicated. We can model this by using a circle first. So we're going to have a unit circle, but it's going to be only in the first quadrant for simplicity. We have 1, 1, right? And say we have our point A here at the origin, and B is always along this line. B is always along this line, because that is the maximum distance that we have here. Now, we can see that since the radius is 1 and that never changes, our maximum value of D here at any value of cosine, or at any angle, is going to just be 1. D equals 1. D of the circle is 1. Now, let's go back to our original problem where we have a square. If we still put our point A here and we try and maximize the distance, well, we're going to go from B here, where D is equal to 1, to a point up here, which is another B. Let's call that B prime. 1 squared plus 1 squared is going to give us our triangle here, 45, 45, 90 triangle, and that's going to be the square root of 2. And then if you come back here for, let's call that B double prime, if you come back here, then it's going to be equal to 1 again. The average maximum distance is going to be between 1 and square root of 2. Let's dive in a little bit more. We just proved that if we have a square, then it doesn't have a uniform maximum value around its edge like a circle does. So what if we start here and, we go chukka 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 up here. Okay, here is the maximum, right? That's the very maximum, and then as we go over here, the distance starts decreasing again until we get to here, and that's the minimum, right? And of course, these have lengths of 1. So what if we have just some random point of B here? Well, we can model this by saying, of course, that this is theta, and this is D. We can use SOHCAHTOA, and well, let's see what we have. We have our adjacent side, and we want our hypotenuse, so we can use CA. So that is just cosine of theta equals 1 over D, because that is our hypotenuse side. And, of course, we want to solve for d because we want the distance. So we multiply by d, divide by cosine, and we get d is equal to 1 over cosine of theta. Now, we have some limitations to this, of course, because it only occurs when theta is from 0 to, well, what is this? This is pi halves, and we're dividing that in half to get pi fourths. Pi over 4. Now we want to find from pi fourths to pi halves. We have a, and we have some random there. We have a here, and we have some distance to the outside to b. Let's call this d. And we have our theta here. Now, of course, that can only go from there and up. Well, you'll notice if we draw a line down, and our theta is in the way, but if we draw a line down, then we have our right triangle. And we know that all four sides are 1, so this must be 1. If we use SOHCAHTOA, then we can see that we have an opposite, and we want a hypotenuse, so we can use sine. Sine of theta is equal to, well, 1 over d. Now we're solving for d, multiply by d, divide by sine of theta, and we get d equals 1 over sine of theta for, well, pi fourths is less than or equal to d, which is less than or equal to, well, we're only going to pi halves here, for theta. This should be a theta. Thank you very much. Okay, now let us combine these two sheets of paper. Now that we know this, let's graph it out. Now I want you guys to stop for a second and use your graphing calculator or Desmos or whichever you want to model this using a calculator, and I'll be back in a second. All right, if you guys got something like this, then good job. Well, what can we do here? If we want to find the average maximum value of d, which is just the average of d in general, we actually have an equation for this. Now, basically what this is saying is for a value of a and b, which are two values of x, then we can use this to find the average under all of this. Well, 1 over b minus a, we have pi halves to 0, pi halves minus 0, times the integral from 0 to pi halves of d with respect to x. Now, these d's have nothing in common. Now we run into another problem. You can't take an integral of something like this by itself because it's two functions. It's not one function. So why don't we break this up further and say all we want to do is add them together. So we go 0 to pi fourths, which is our first pi fourths, which is our first domain of 1 over cosine theta, d theta, and we add it to, now that we have these two, we can solve for them. So we're actually going to get the same values for both of these. So we could have only found 1 and multiplied by 2, but I want to show you this longhand. So we evaluate this in our calculators, and we're going to get that is our average maximum value. But we're not done. We know now that an average is a maximum plus a minimum divided by 2. And we found the average maximum is 1.1222. So what do we have to do now? Well, we take the maximum of 1.1222 plus the minimum of 0 and divide by 2. We are going to get 0.5611. That is the average distance d between a and b, where a are random uniform points on the unit square. Thanks for watching, everyone.